Hi everyone, welcome back. So today we're going to take a look at lesson 1-5, which is solving inequalities. So we're going to go ahead and do that. Again, pause the video as needed for any time you need to take notes or one more time to work on a problem. Go ahead and do that, but we're going to go ahead and get started. So we're going to do a brief overview of interval notation and inequality notation. So this is to go ahead and show you how they're related, and that eventually during class, we will be moving more towards interval notation. So this is just like a nice little intro to it. So to go ahead and do it, we're going to watch a brief video.
What I hope to do in this video is get familiar with the notion of an interval. Is that we can show an interval or interval notation. So right over here I have a number line. Now let's say I wanted to talk about the interval on the number line that goes from, let's say, from -3 to 2. So I care about this. Let me do this in a different color. Let's say I care about this interval right over here. So I care about all of the numbers from -3 to 2. So in order to be more precise, I have to be clear. Am I including -3 and 2, or am I not including -3 and 2? Or maybe I'm just including one of them. So if I'm including -3 and 2, then I would fill them in. So this right over here, I'm filling -3 and 2 in, which means that -3 and 2 are part of this interval. And when you include the endpoints, this is called a closed interval. Closed interval. Closed interval. And I just showed you how I can depict it on a number line by actually filling in the endpoints. And there's multiple ways to talk about this interval mathematically. I could say that this is all of the, let's say this number line is showing different values for x. I could say these are all of the x's that are between -3 and 2 and 2. And notice I have -3 is less than or equal to x. So that's telling us that x could be equal to -3. And then we have x is less than or equal to +2. So that means that x could be equal to +2. So it is a closed interval. Now another way that we could depict this closed interval is we could say, okay, we're talking about the interval between, and we could use brackets because it's a closed interval, -3 and 2. And once again, I'm using brackets here. These brackets tell us that we include, so this bracket on the left say that we include -3, and this bracket on the right says that we include +2 in our interval. Now sometimes you might see things written a little bit more mathy. You might see something like that, like x is a member of the real numbers such that. So, and I could put these curly brackets around like this. These curly brackets say that we're talking about a set of values, and we're saying the set of all x's that are a member of the real numbers. So this is just fancy math notation to say member of the real numbers. I'm using the Greek letter epsilon right over here to say member of the real numbers, such that this vertical line here means such that -3 is less than x is less than, or -3 is less than or equal to x is less than or equal to 2. I could also write it this way. I could write x is a member of the real numbers such that x is a member of this closed set. I'm including the endpoints here. So these are all different ways of denoting or depicting the same interval. But let's do some more examples here. So let me draw a number line again. So number line. And now let me just do an open interval. An open interval just so that we clearly can see the difference. So let's say that I want to talk about the values between -1 and 4. Let me do this in a different color. So the values between -1 and 4. But I don't want to include -1 and 4. So this is going to be an open interval. So I'm not going to include 4, and I'm not going to include -1. Notice I have open circles here. Over here I had closed circles. The closed circles told me that I included -3 and 2. Now I have open circles here. So that says that I'm not. It's all the values in between -1 and 4. So -1 or -0.9999999 is going to be included, but -1 is not going to be included. And 3.9999999 is going to be included, but 4 is not going to be included. So how would we, what would be the notation for this? Well, here we could say x is going to be a member of the real numbers such that -1, I'm not going to say less than or equal to, because x can't be equal to -1. So -1 is strictly less than x, is strictly less than 4. Notice, not less than or equal, because I can't be equal to 4. 4 is not included. So that's one way to say it. Or another way, I could write it like this. X is a member of the real numbers such that x is a member of, now the interval is from -1 to 4, but I'm not going to use these brackets. These brackets say, hey, let me include the endpoints, but I'm not going to include them. So I'm going to put the parentheses right over here. The parentheses. So this tells us that we're dealing with an open interval. So this right over here, let me make it clear. This is an open interval. Now you're probably wondering, okay, in this case, both endpoints were included. It's a closed interval. In this case, both endpoints were excluded. It's an open interval. Can you have things that have one endpoint included and one endpoint excluded? And the answer is absolutely. Let's see an example of that. So I'll get another number line here. Another number line. And let's say that we want to, and actually let me do it the other way around. Let me write it first, and then I'll graph it. So let's say we're thinking about all of the x's that are a member of the real numbers such that, let's say -4, let's say -4 is not included, is less than x, is less than or equal to -1. So now -1 is included. So we're not going to include -4. -4 is strictly less than, not less than or equal to. So x can't be equal to -4, so open circle there. But x could be equal to -1, it has to be less than or equal to -1. So it could be equal to -1, so I'm going to fill that in right over there. And then it's everything in between. If I want to write it with this notation, I could write x is a member of the real numbers such that x is a member of the interval. So it's going to go between -4 and -1. But we're not including -4. We have an open circle here, so I'm going to put a parentheses on that side. But we are including -1. We are including -1. So we put a bracket on that side. And so that would be, that right over there would be the notation. Now there's other things that you could do with interval notation. You could say, well, hey, everything except for some value. So let me give another example of, let's get another example here. Let's say that we want to talk about all the real numbers except for 1. So we want to include all of the real numbers, except for 1. Except for 1. So we're going to exclude 1 right over here. So open circle, but it can be any other real number. So how would we denote this? Well, we could write x is a member of the real numbers such that x does not equal 1. So here I'm saying, look, x can be a member of the real numbers, but x cannot be equal to 1. It can be anything else, but it cannot be equal to 1. And there's other ways of denoting this exact same interval. You could say x is a member of the real numbers such that x is, x is less than 1 or x is greater than 1. So you could write it just like that. Or you could do something interesting. This is the one that I would use. This is the shortest, and it makes it very clear. Saying, hey, everything except for 1. But you could even do something fancy, like you could say, x is a member of the real numbers such that x is a member of the set going from -infinity to 1, not including 1, or x is a member of the set going from, or a member of the interval going from 1, not including 1, all the way to positive infinity. And when you're talking about negative infinity or positive infinity, you always put a parentheses, and the view there is you can never include everything all the way up to infinity. It needs to be at least open at that endpoint, because infinity just keeps going on and on. So you always want to put a parentheses if you're talking about infinity or negative infinity. It's not really an endpoint; it keeps going on and on forever. So you use the notation for open interval at least at that end. And notice we're not including 1 either. So if x is a member of this interval or that interval, it essentially can be anything other than 1. But this would have been the simplest notation to describe that.
All right, so that was a brief overview of interval notation. It is something that you need to be aware of, that you will start seeing both of them. We will slowly move only to basically really using interval notation, with every now and then inequality popping up. So we're going to go ahead and solving inequalities. Lesson 1-5. So here we have, for our first example, solve 4y minus 3 is less than 5y plus 2. Graph the solution set on a number line. So we have our original equation. So we're going to go ahead and subtract 4y from both sides so that we can isolate y on one. We're going to isolate it on the right. So now we simplify to get negative 3 is less than y plus 2. And now we're going to subtract 2 from both sides and simplify to get negative 5 is less than y. Here they can go ahead and say rewrite with y first, so y is greater than negative 5. This is more of a preference and maybe just a setup that we like to see. It's easier for us to go ahead and have the variable first. It does sort of help when you're writing out your number line, but these are actually both acceptable. And then the way we would write this in our interval notation is we would say negative 5, comma, infinity. And infinity always gets parentheses. This is a parenthesis because it's a less than symbol, so we're not including the value of negative 5. So any number that is greater than negative 5 is a solution to this inequality. And so when we draw this on the number line, notice we have an open circle here. This is very important for when you're doing this, because it does change your answer if you do not use the correct symbol. So a circle means that this point is not included in the solution set, hence also why we would also use parentheses. Go ahead and pause if you need more time to write the notes. All right, so here's your first U try. Which graph represents the solution to 6x minus 2 is less than 5x plus 7? Go ahead and pause so you have time to work this out. All right, so we're going to go ahead and isolate x on one side by subtracting 5x from both sides. In doing that, we're left with x minus 2 is less than 7. We're going to add 2 to both sides. And we'll end up with x is less than 9. If you want to go ahead and add 2 at the same time up here, you could have. You could have done the plus 2 the same time I did the minus 5x. That is completely fine. But we're going to go ahead and do this. So because we have a less than symbol, so if you need to go ahead and write this down, open symbols are parentheses, open circles. They are less than, greater than symbols. Closed circles have brackets. They have less than, greater, equal to, greater than, equal to. So they have the equal to symbols. And if we have arrows, as we do here, that means it's going to plus or minus infinity. But they would also get parentheses, and you might see the less than, greater than symbols. So because this is a less than symbol, I can cross out C and D because they have closed circles. And if you're not sure which direction to shade, come up with a true statement. So here I know 8 is less than 9. So I'm going to shade on the side that there's 8. And by that, we get a All right, moving on to our next example. We have 12 is less than or equal to negative 3p, negative 0.3p. Graph the solution set on a number line. So we're going to take our original equation and we're going to go ahead and divide by negative 0.3. And when we do that, do remember, take a look that it says reversing the inequality symbol here. So remember, when we multiply or divide by a negative with inequalities, we flip the symbol. So this simplifies to negative 40 is less than or equal to p. And again, this could be a preference. Negative 40 less than p is less than or equal to p is completely fine. Or you can rewrite it as p is greater than or equal to negative 40. These mean the exact same thing. It's just more of a preference of which one we write. If we were to write this in interval notation, we would go ahead and put bracket 40 because it's an equal to symbol and go to, or negative 40 by the way, and goes to infinity. And so when we graph that, we do get a closed circle to mean that this point is in the solution set. All right, moving on to your U-try. What is the solution to negative 3x is greater than or equal to 21? Go ahead and pause the video to give yourself time to work this one out. All right, so to start off with, we're going to go ahead and divide by negative 3 on both sides. And so by doing that, the first thing you should do is go ahead and flip your sign. So we'll get x by itself. 21 divided by negative 3 is negative 7. So here we gotta look at our answer choices. They all have closed circles, so that's fine. Next, we're gonna look for negative 7. So that crosses out C and D. If you got C or D, you probably forgot to divide by a negative. So then we're gonna do nice, since they were really nice, they went ahead and gave us the inequalities that they graphed. So our answer here is B. All right, example 3, solve negative x is greater than x minus 7 over 2. Graph the solution on a number line. So we're going to take our original equation, and it says to multiply each side by 2. So we're going to multiply each side by 2. By doing that, we cancel out the dividing 2 over here. And 2 times negative x is negative 2x. We're then going to subtract x. That is the same thing as saying you're adding a negative x. And doing that, the x's cancel out. And we're left with negative 3x is greater than negative 7. We're going to go ahead and divide by negative 3 to get x is less than 7/3. So again, remember, since we divide by a negative, we need to flip the sign. So the solution set is x such that x is less than 7/3. When you're graphing this, you need to remember that 7/3 is the same thing as 2 and 1/3. So it was nice they broke up each section between the two whole numbers into thirds. But you should know that 7/3 is the same thing as 2 and 1/3. All right, so what is the solution in negative 2x is greater than x plus 5 over 3? Go ahead and pause the video so you have time to try it on your own. All right, so we're going to head and get started. We're going to take our negative 2x, x plus 5 over 3. We're going to multiply each side by 3. In doing that, we cancel out our 3's over here, and we're left with negative 6x is greater than x plus 5. Now we're going to go ahead and subtract 5. Why am I saying subtract 5 now? We're going to go ahead and subtract x from both sides so we can isolate x onto one side. So we're going to do minus x minus x and get negative 7x is greater than 5. We're going to divide by negative 7. And we get x is less than negative 5/7. If you wanted to over here at this point, you could have gone a different route, and we could have, instead of subtracting x from both sides, I could have done a little bit of different work. And we could have added 6x to both sides if you wanted to get rid of the negative. But I want to go ahead and show you this because the whole this kind of explains why you would flip the sign when you divide by a negative. When we do this, the 6x's go away and we're left with 0 is greater than 7x plus 5. So we're going to go ahead and subtract 5 from both sides. And we get negative 5 is greater than 7x. And now divide by 7. And so we get negative 5/7 is greater than x. Notice the inequality that the mouth is facing in the same direction. So this is literally the same thing as saying x is less than negative 5/7. So this was a method that you could use if you're one of the people who will forget to go ahead and flip your sign. You can go ahead and go this route and do a little bit extra work. It's not too bad, but this also shows you that you get the same thing and why you need to actually flip that sign. Looking at our answer choices, if we start out with a less than or greater than, if we start out with what we know is going to be an open circle, we're going to finish with an open circle. So C and D get crossed out. I'm not even going to look at it. And we're saying x is less than negative 5/7. So we're going to go with B. We could also write this as parenthesis negative infinity, comma, negative 5/7, and parentheses. So if I wanted to look at interval notation, that's what it would look like. All right, so for our last example, we do have a word problem. We're talking about Javier is at a gas station. So Javier has at most $15 to spend today. He buys a bag of pretzels and a bottle of juice for $2.59. If gasoline at this store costs $3.39 per gallon, how many gallons of gas to the nearest tenth of a gallon can Javier buy for his car? So this is something like, if you're on a budget, this is actually some things you think about when you go and do this. So when we're looking at this, we're going to let G be the number of gallons of gasoline that Javier buys. And as a reminder that total cost that we spend on gasoline is going to be $3.39 times G. We have a set cost for the pretzels and juice. So we're just going to add this for the total cost that we know that we can't spend more than $15. So you got to think that he has a $10 bill and a $5 bill, and that's all he has. He can't spend more because at the gas station, they're like, or go to the store, they're not going to let you buy more than what you have. So I do really like how they set this up for the formula and inequality. So here we're going to take the cost of the juice and the pretzel plus the cost of the gasoline, and that is equal to or less than $2.15. We get is equal to or less than by saying he has at most $15 to spend. So that at most tells me that I need to be less than or equal to 15. So we get $2.59 from the cost of juice, adding to the cost of gasoline, which is $3.39, and we're going to use the less than equal to symbol with 15. And we're using $15, so we are going to the 2 decimal places. So we take our original equation, and we are going to solve for G. So first we subtract $2.59 from both sides. And when we do that, we get $3.39G is less than or equal to $12.41. So now we're going to go ahead and divide by $3.39 on both sides. And we're going to get G is less than or equal to 3.6. As a reminder, they did tell us to round to the 3rd decimal place, or I'm sorry, to the 10th decimal place, which is 1 decimal. So our answer is that Javier can buy 3.6 gallons of gasoline for his car. And technically, 12.41 over 339 is a little greater than 3.6, but we are told to round. And you can actually go into the gas and say, I want 3.6 gasoline. They can tally it up and put that much that you can get. So this is actually something you kind of could do in real life if you're on a budget. All right, so for our last you try, Jeb wants to rent a car for his vacation. Value Cars rents cars for $25 per day plus 25 cents per mile. How far can he drive for one day if he wants to spend no more than $200 on a car rental? So go ahead and pause this so that you can go ahead and come up with your equation or your inequality and work it out. All right, so we're going to go ahead and write our inequality first. So we know he's going to spend $25 no matter what. And that we're going to spend 25 cents per mile. So I'm going to use M for mile. You can use X if you want to use X, that's completely fine. And he wants to spend less than or at most $200. I can spend less than $200 and be okay, but I can't spend more. So the first thing we're going to do is go ahead and subtract 25 from both sides. In doing that, we are left with 0.25 M is less than or equal to 175. We're now going to divide by 0.25. So dividing by a quarter, so 25 cents by 0.25. This is going to be the same thing as multiplying by 4. So you can go ahead and do this in the calculator, but I'm going to go ahead and do it right here. So 5 times 4 is 20. I'm going to carry the 2. 7 times 4 is 28. Plus 2 is 30. I'm going to carry the 3. 1 times 4 is 4. Plus 3 is 700. Here, or 7. So we're going to get M is less than or equal to 700. So looking at that, I'm going to cross out B and D because they say 800. And I want to remember, I can't go over 700, so my answer is A, up to 700 miles. That is the end of the lesson. Again, you can go back and rewind and pause as needed for you to take notes, and I will see you next time.